Hi everyone, I continue on topic 4. This is video number 4. And here I see this question. So I want to do with two methods because I want to show you. I want to show you some mistakes that I just come across when I'm marking. And I just want to teach you. Try my best to teach you those. So here, as I said, all logarithm one side and numbers all the other side, and then I can combine them to one logarithm or one ln, and then I can go by definition of logarithm and ln. Okay, so let's do that. So this is all ln one side, so ln 6 plus ln x minus 2 all together. Okay, so minus ln 3x minus 2 equals 0. Okay, and then it is ln 6x minus 12 divided by 3x minus 2 all together equals 0. Okay, so it is logarithm 6x minus 12 over 3x minus 2 base e equals 0, and then it is 6x minus 12 over 3x minus 2 equal e power 0 is this one, which is 1. Okay, and then I just solve it. So this is just one equation I am solving. Okay, so it is 6x minus 12. Oops. Okay, so it's 1 second. Okay, minus 12 equal 3x minus 2. I do cross multiplication, and then it is 6x minus 3x, and the other one, so it's minus 2 plus 12. Okay, so I just change the color just to have all the same. Okay, so that, and then this is 3x equal 10, and then x is 10 over 3, which is 1 over 3. Okay, that's the answer. Okay, or I can say, okay, so this is exact answer, but I can say for example, if this is exact, but if I want 3 significant digit, did I have anything there? No, but for example, if I want, so it is just want to say how many, what is the answer, just approximately it is 3.3 forever, and that's 3.33. okay, so that's the answer. Then I have to check if the answer is valid. Oh, okay, I have to see logarithm x minus 2, logarithm 3x minus 2. Okay, so logarithm 3 this minus 2, that's valid. Oh, sorry, ln, that doesn't matter, both of them are. So, and ln 3x, yes, ln 3x minus 2, so 3 times 3.33, okay, that's almost 9. Okay, 9 point something, and then minus 2, yes, that's valid. So the answer is valid, so this is the answer. Okay, so I want to show you other method here. Sometimes I see a student, they do this. Okay, they do ln 6x minus 12. Okay, which is because you have addition, you multiply them, yes, equal ln 3x minus 2, and then I see a student, they cancel ln. I know what you mean, but mathematically this is wrong. Mathematically that's wrong when I say I cancel. No, I don't do that. It doesn't mean that doesn't make any sense that I say I cancel, because it's not ln multiple, it's ln of. It's like f of x, not f multiple x. Doesn't make any sense to say I cancel. Okay, so if I say I cancel, so that's wrong here. So I can say, okay, ln 6x minus 12 equal ln 3x minus 2, and then I do e power both sides. I say, yes, I know it has the same result, like I cancel ln, but doesn't make any sense if I say I cancel ln. I just want to teach you just to approach mathematical questions just correctly, okay, mathematically correct. Okay, so you do e power both sides. When I do to both sides, I didn't do anything wrong. So e power ln 6x minus 12 is e power ln 3x minus 2. And then e and ln, when they come beside each other, it's like a function and inverse of the function. They come beside each other, they cancel each other. Okay, so it is 6x minus 12 equal 3x minus 2. And then you can go to here and continue to here. Okay, so the same thing. Okay, but because I see a student, they would say, I cancel ln from both sides, I just wanted to show you. Okay, if you don't want to do that, you can have all ln one side, all numbers the other side, ln one side. You can use properties of log or ln or law rules. You can use them to combine them to one ln or one log, and then use the definition. Like here I use the definition, so I don't need to even say, okay, e power both side or 10 power both side and those things. Okay, yeah. How about this one? So again, I say all ln one side. Okay, so it is ln 5x plus 2 minus ln x plus 6 minus ln 4 equals 0. So this is ln 5x plus 2 divided by this equals 0. And then when I say equals 0, it means e power 0. So it is 5x plus 2 over that equal 1. Okay, so when I have ln or log, see, if I have log x equal 1, means x is 10. If I have log x space a equal 1, x is a. If I have ln x equal 1, x is e. If I have log x equal 0, okay, so x is 1, because 10 power 0 is 1. If I have log x base a is 1, again x is 1. If I have ln x is 0, e power 0 is 1. And then if I have this equal 0, again x is 1. Okay, ln 1 is 0. Log 1 is 0 for any base. Okay, any base. So let me see, 0 0 0 1 1 1 and e a 10. Okay, so yes. Okay, so how about this? Okay, so you do 5x plus 2 equal x, so 4x plus 24, and then 5x minus 4x, 24 minus 2, and this is x, that's x, right? That's x equal 22. That's the answer. Okay, x equal 22. And then we can check if the answer is valid. Okay, so 5x plus 2 and x plus 6. Okay, so 5x plus 2 and x plus 6 and 4. Okay, 4 is positive, so it's okay. X plus 6 is 22 plus 6. Yes, it's positive. That's fine. And 5 times 22 plus 2 is also positive. That's fine. So the answer is valid. Yes, it is valid. Okay, because when I sub inside ln is positive, and makes sense, because if it's negative, it's not defined for that number. Okay, so the last question here, I think it is the last one. Yes, the last question of this type is this one. Okay, remember here I have 2. I have to be careful with that. When I have a number beside, I have to take it as power. Otherwise, I cannot combine them. So it's ln x squared minus ln this equal 1. So then it is ln x squared divided by that equal 1. Then it is x squared over 1 minus x. So that's logarithm base e equal 1. And then x squared over 1 minus x is e. Okay, from now it just math 171, you are solving one equation. So it's x squared equal e minus ex. So this is x squared plus ex minus e equals 0, right? Okay, so then I just solve it. So this is just one equation. Okay, so see, I have a equal, okay, so yeah, I have a equal 1, b equal e, and c equal minus e. So x is minus e plus minus e squared minus 4 times 1 times minus e over 2, which is minus e plus minus e squared plus 4e over 2. That's the answer. Okay, this is exact answer. That's exact. Then I use my calculator to find the answer. So when I use my calculator, the answer is x equals 0.7775, and that's almost 0.778, and x is minus 3.495, that's almost minus 3.50. When I underline that, do that. Okay, this is valid here because, okay, look at this, x squared 1 minus x. Okay, so check this. If I have a ln 0.778 squared, yes, that's valid. And ln of 1 minus that, am I right? Is it 1 minus x? Yes. 1 minus this, also valid, because that's also 1 minus that is also positive. Okay, so that's valid. Okay, so I do that and I say this is valid because of this. Okay, how about here? Okay, so this. Okay, so minus 3.50 squared is positive, but 1 minus minus, am I right? Let me see. Is it 1 minus x? Oh, sorry. I took x. I took 2 to just the power, but it's not really x squared. No, it is x ln x. Yes, so must be that. Okay, because I change it. Okay, so that's that, and then I would say, okay, so minus 3.50 is negative, so no, it's not valid. Okay, so this is not valid here, because ln of this number is not defined. Ln of this number, which is negative, is not defined. So inside ln as input must be positive. Look at this. This is positive when I use my calculator. This is 1 minus something less than 1. So that's positive. This is also positive. Okay, so these are all positive. Okay, so now this is application question. So that's just based on your knowledge in chemistry. So I'm not going to talk about chemistry part. I don't want to give you wrong information. Of course, you know much more than me in this case. Okay, so I'm just going to talk about just the math part. Okay, by definition, pH is minus log this formula. Okay, this symbol, if you pay attention, this symbol is molarity. Okay, the more commonly used form of pH is minus log this one. Okay, so minus log this one, the more commonly. Okay, so similarly, when I have POH, then I would have this. Oops, then I have, okay, so this one. Okay, minus logarithm that formula. Okay, and also I know when I multiply these two, it is equal that. Okay, so now I want to make a formula just here between here. I want to make a formula between pH and POH if I can. Okay, so let's do it. Okay, see, I multiply this with this, which is 1.00 multiple 10 power minus 4. This means 1, but it's 1.00 because we are sure about those digits. Mathematically, it's 1. For my calculator, that's 1. But 1.00, you are sure about 2 digits after the decimal. So you cannot ignore them. Okay, so this is 3 significant digits. Okay, so I have that, right? Okay, what happens if I do log of both sides? Okay. Oh, okay, so log of this is log of this. Okay, which is log of first one plus log of second one, which is log of 10 power that. Okay, so this one is minus pH. The other one is minus POH. And the answer here is minus 14 logarithm 10, which is minus 14. Okay, so the formula that I have is pH plus POH is 14. This is what I get from the first part. Okay, when I consider the green formula, when I consider logarithm, when I consider I can use logarithm for both sides, when I remember logarithm rules from the previous topic, that page, and then I can use it here. Oh, okay, so now I have this and I can use it. Okay, so now what is pH of a solution that contains this many gram of dissolved HCl in a 20-liter solution? Okay, so what is that? So we are finding this when I have this in this. Okay, and remember molarity is mole per milliliter. Okay, so per mole per sorry, mole per liter. Yeah, so per liter is okay, but I don't have mole here, I just have gram. Okay, see, I want to go from 1.201 gram of HCl. I want to go to pH. Can I go to pH directly? Okay, what is pH? pH is minus logarithm this. Okay, minus logarithm of the, so just molarity of that. Okay, so okay, I have this, I remember I have this. Okay, and I want to go to this one. Can I go directly? No. Okay, I go from here, which is gram, I go to mole. I need it because I need molarity, so I go to mole of HCl. Then from mole of HCl I go to mole of this one. Okay, and then from mole of this one I go to this one, and then from this one I go to this one. Okay, so let's do it. 1.201 gram HCl multiple. I want to cancel gram and I want to bring mole. Okay, so I need molar mass. Do I have it here? Yes, it is here. Okay, so gram goes to the denominator because I want to cancel gram. This is the way that we did last semester. So gram HCl and 1 mole HCl, right? Multiple. Okay, so 1 mole HCl has how many mole of H plus? Oh, okay, so this one I need to look at this. It is assumed that HCl is a strong acid and it goes completely into this and these ions. Okay, so these ions that we have here. Oh, okay, so means HCl goes to this and this. Okay, so 1 1, right? So I have 1 and 1 and 1. This is the reaction when I read the question. Okay, so then when I look at that one, I see it is 1 mole of this one. Okay, oh, perfect. Okay, so which is equal. Okay, so here I am. Okay, so here I can go to this one to mole, and then I can go to molarity using the 20 liter. Okay, so I do have okay, yes, so this is okay. So this one I cancel this and this, I cancel this and this, and what is staying is this one and this one and this one and this one and this one, and then I can find the answer. So the answer is 0.03294 mole of this. Okay, so I need to show, see it, all of them are 3 significant digits, so I can go to 3 significant digits, but I don't want to round in the middle of the question. So that's why you see more significant digits, because I want to round at the end. I don't want to carry over all the you know, all the just errors with me, because if I round in between, that's not great. So I would have a little bit difference with the real answer. Okay, so you round at the end, so that's why here I show 4, so I don't round, I show 4 significant digits. Okay, so then I go to molarity of that, okay, which is 0.03294 mole of this divided by 20 gram. Oh, sorry, 20 liter. 20, that's mole per liter. Yeah, mole per liter molarity. So this is 1.647 multiple 10 power minus 3. Okay, so that's the answer. So now I have this one. Okay, now I have this one. So here I have this one, right? Oh, okay. So now if I want to go to the last step, I have to do what? Minus logarithm. Okay, so pH is minus logarithm of 1.647 times 10 power minus 3. Okay, and the answer is 2.783. I underline that, check that, it is almost 2.78 is the answer. So pH is 2.78. See, when I read the question, I see I have gram and I have liter. From gram, I go to mole. From mole of one item, I go to mole of the other item. And then from mole and liter that I have, I go to molarity. And then I do minus log to find pH. Okay? So, how about this one here? B and C and D. Yeah. Yes, B. So, what is pH of a solution that contains this many gram? So, this many gram of this KOH and this many liter here. Okay? So, we want to find pH. Also, it says, look at this. It says this one. Yeah, I have this one. I want to use the same. Okay, so the same here. Okay, like the same. Okay, so here, see, it says KOH is K plus here plus OH minus. Okay, so these ions. Okay, 1 1 1. So 1 1 1. Okay, so I remember that. Now, what do I have and what do I want? In Math 171, when I was just talking about these kind of questions, I always said, okay, you have to see what do you have, what do you want to, where do you want to go, and how can you go there. Okay, listen. So you have 0.561 gram KOH, and you want to go to pH, right? Yes, you want to go to pH. Okay, so let me see how can I do that. Okay, from gram of this, I can go to mole of this. From mole of this, I can go to mole of this one. From mole of this one, I can go to molarity of this one. From molarity of this one, I can go to POH, right? And then from POH, I can go to, let me see, what was POH here? Am I right? Okay, so POH is, yes, POH is minus logarithm OH minus, yes, because I have OH minus, yes, so I do that. Okay, POH, and then from POH, I go to OH. So I have to see what do I have, where do I want to go, and how can I go. Okay, yeah. Okay, so I start from here, 0.561. Okay, so 0.561 gram KOH. I want to cancel gram and I want to bring mole. Okay, so what do I have? 56.1. Okay, so 56.1 gram KOH and 1 mole KOH. Okay, so now I want to go from 1 mole KOH. Okay, so whatever I have top and I want to cancel, I go to the denominator. Whatever is bottom and I want to cancel, I write it top. Okay, so 1 mole of this, so I write it 1 mole of this. So I just change the color that you see. Okay, 1 mole of this is 1 mole of OH minus. Okay, and I find the answer here. Okay, so I find the answer. I cancel this and this. I cancel this and this. What is staying? This is staying, this is staying, this is staying, and this is staying. So the answer is 0.01, oopsie, 0.01 mole OH minus. Okay, okay, so now I do 0.01 mole OH minus divided by how many liter? Okay, so 10 liter. Am I right? I just remember that. Yes, 10 liter I do have. Okay, so this gives me this one, which is 0.001, which is 10 power minus 3, right? Okay, so far so good. Okay, so I do have just finished this. Okay, now from here I can go to POH. Okay, so POH is minus logarithm this, which is minus logarithm 10 power minus 3, which is right, which is, yes, okay, so it is POH is, yes, that's 3 logarithm 10, which is 3. Okay, POH is 3. Okay, POH is 3, and then OH is, for sure, OH is, what do I have between POH and OH? So yes, I go to the previous page and see what do I have there. Let's what I found here. Okay, POH and OH, POH and pH, when I add them, I can see, yes, I can see it's the answer is 14. Okay, so POH, and I'm looking for pH here. Yes, okay, so pH, okay, so yes, pH here is 14 minus POH, which is 11. Okay, 11 is the answer. Okay, so pH is that. Yes, yeah. Okay, so now I can continue to the next one. So a lake in Muskoka region has a pH of 4. Clean rainwater has a pH of 5.60. So it doesn't you really don't notice that's too much different, right? So that's a like large difference. So how many times more acidic is the lake compared to the rainwater? So when it says how many, so just acidic, so we have to compare, so this, so we have to compare, so this one for both, okay, so pH 4 and pH 5.6. okay, so 4, which is pH, and I know it is minus logarithm this one. Okay, so this means logarithm this guy is minus 4. This means if I want to release and find this, what should I do? Remember, logarithm is base 10, so it is 10 power minus 4. Oh, okay, so that's the answer here. Okay. So similarly, I can do for the other one. So similarly for the other one, this guy is 10 power minus 5.6, minus 5.60, right? So yes. So one of them so this is for clean rainwater, and that's for so Muskoka region. Yes, the Muskoka Lake. Okay, so Muskoka Lake is this one. So here I do Muskoka Lake, and here I do clean rainwater. Okay, so then I have to compare them, right? So I have to compare them. So 10 power minus 400, 10 power minus 5.60, which is, what is the answer? It is 10 power minus 4 plus 5.6. Mathematically, this is 10 power 1.6, if I'm right. Okay, so let me see. Yes, it is that. And when I use my calculator, let me use my calculator. So 10 power 1.6. Yes, it's 39.8. Okay, so I can underline and check that, and I can say it is almost 40 this. Okay, yes, it's 40.0. So I can say a lake in Muskoka region. Okay, I can write it here. A lake in Muskoka, am I right here? Muskoka, yes, Muskoka region is 40 times acidic than clean rainwater. Okay, so I don't talk about the chemistry part. For that, you know much more than me. I want to just show you the application of this in just mathematics, just a mathematical application, right? So how about this one? The pH of water in a small lake in northern Quebec, okay, has dropped from this to this. See, it's not a really big difference in 3 years. How many times more acidic is it now? Exactly the same. You are comparing. Okay, so pH is minus logarithm this. Okay, so what is pH here? Okay, so pH is so pH is changing from 5.40 to 4.80. It doesn't really show like a big difference. Okay, so but 5.40 is minus logarithm this. Logarithm of this one is minus 5.40, right? Okay, so how can I release that? Okay, so this one is, I do 10 power, because logarithm is just logarithm of that base 10. So I do 10. See, I have, okay, so I want to show you. So this is logarithm, this guy base 10 is minus that, and then this one is 10 power, this is this one, so it is 10 power minus 5.40. I can do the same thing for after 3 years. Okay, so after 3 years, what happened? After 3 years, I have 4.80 minus log, so equal minus log that. Yes, and then I have logarithm of this equal minus, which is this, equal 10 power minus this. So let's compare them. So how do you compare? Okay, so 10 this, oh my goodness. Okay, so 10 power minus 5.6, am I right? Yeah, Let me see, 5.40. Yes, sorry, 5.40. Yes. Okay, so this is 10 power 0.6 mathematically. Let me see. Yes, because it is 10 power 5.40 minus 4.80, which is 10 power 0.6. That doesn't make that doesn't show it's like a very large number. Okay, so but when I find the answer, it's point. Okay, let me just to make sure, because I'm just okay. So 10 power 0.6. Yes, 3.98. 3.98. So I underline that, I check that, it is almost 4.0. Okay, so after 3 years it is 4 times. Okay, so when pH is changing from 5.4 to 4.8, so the lake is almost, because I rounded, 4 times more acidic. Yeah, okay, so here, so yeah, when I was this, we used to say pH, so that's just what I remember. I don't go to just chemistry part, just talk about math part here. I just wanted to show you the application here. Okay, so we finished, this is video number 4. We finished this topic 4, so we continue to the next topic in the next video. Thank you.